So looking at the topics, so last test ended with Markov chains. Give me a second. Will be ended with Markov chains, but didn't have fixed vector and didn't have the question that's on the review, which is find the first return time, find the amount of time to go from one to another time. Then the Poisson process, the three types of questions, all the different types of queues, the finite and the infinite, MM1, MM2, so on. Stock, what I mean by that is the stock now is $50 and it's either going to go up to $100, down to $20, give me the price. And then the Black-Scholes equation, and then the thing that we did on Monday. So the test will look similar to the one from last spring, because I think the fall, I gave it earlier, so it's quite a bit different in terms of topics. But it should be pretty similar to in length to what I gave last spring. So they were given the 60, 65 minutes. I'll give you, what do I say, 425. I'm not sure why I don't just say 555, so an hour and a half. So you have an hour and a half. And even with that, a couple things are you still can put it in if it's over time. So it's not like suddenly you can't hand it in anymore. So if you go for that, then it'll just have a little mark next to you that says late. And as long as it's not too much past it, I wouldn't worry about it. Also, a couple things about it, similar to what was on the take home. If you can, it makes it easier for me if you submit it as a PDF. If you can't, don't worry about it. Just whatever you have. So a JPEG or whatever, as long as it's one of the ones that's fairly common, because otherwise I might not be able to open it. And if you have questions, if you have problems either opening it up at the beginning, which is in some ways why I'm opening it early, or if you have trouble submitting it, then send me an email. If you have trouble getting it, send me an email, obviously, right away. If you have trouble submitting it on Blackboard, just send me an email with it as an attachment, and that would also be fine. So roughly I have an hour and a half for hopefully a 60-minute test, with the idea that if you go a little over, it's not a big. So before I start looking at the review questions themselves, any general questions about how this is going to work? Okay, so you have answers to the actual review. So I have a few comments I want to make, and then we'll go over questions you have. So let me start with a few comments. So one thing is, you can see that there are a lot of different topics. So there's some things I can do to make some of the questions quicker. So for example, and I'll go through some of those. So for example, in 8, no, there won't be 13 questions. It'll be, as I said, the length will be similar to, if you look at the one from last spring, it should be pretty similar to that, and I forget how many there were. Is that how many there were? Also, it depends how you count it, because some have more than one part. So 8 was this one. Let me change it. See if that works. So 0.5, 0.3, 0.2, 0.3, 0.5. Yeah. So this one we talked about when we were doing it, but it's been a while, so let me remind you. So given this, What is the fixed vector? 0.3. So the first row is 0.5, 0.3, 0.2. Second row is 0.3, 0.5, 0.2, and then 0.2, 0.2, 0.6. So what is the fixed vector for this? And the idea is you can read it off. As I said, we did this when we were doing it, however long ago, it was a month and a half ago. In some ways, if you think about it, it makes sense, which is here, notice the sum of all the columns is 1, which means they have the same weight, and therefore it is just all 1/3. So a way I can shorten this problem where I then ask what's the first return time to go from state 1 to state 1, or how long does it take you to go from state 1 to state 3 for the first time? I could make the problem shorter by making the sum of the columns equal to 1. So obviously the sum of the rows is always 1 because it's probability. So the idea is if sum of all columns 1 goes to fixed vector is just 1 over the number of columns. And as I said, you can kind of see that because if you look at the sum, they're all 1s, which implies that they all have equal weight. So obviously you can still do the usual way. You can do x, y, 1 minus x minus y times t is equal to x, y times 1 minus x minus y. But the idea is if I give you something like this, and since I'm giving this, I'm kind of implying that it's a fairly strong probability C, one of these. So if the sum of the columns is 1, then the fixed vector is just something you can read off. You don't have to do a calculation at all. So from here, then the rest of it would be the same. So if I asked you first return time from 1 to 1, it'd be 1 over 1/3, so 3. And if I want to go from 1 to 3 for the first time, I'd make the third row into 0, 0, 1 and do the same thing that was on the reading. So any other questions on the type of problem? Okay. So the second one I had a comment on was number 10 is meant to be a longer problem, but since this semester we're doing the test later, there's more material on the second test. And so nothing like 10 will come up on your test. So 10 is kind of a solving in a general way. It does give you an interesting insight, which is as the second price x goes to infinity, there still is a maximum that you would charge for the options, but nothing that general type will be on the test. So you don't have to worry about 10. And then I want to look at 11 because, as I said in the email, I kind of messed that up. So let me do that one. And again, I have to drop some stuff. So let me just tell you, 11a is in the background, but for us, isn't really going to come up. So it will not come up. So it's A. So that's what I messed up. For some reason I think because I was thinking the next one, it should be A. So that's why I messed up. Otherwise, in some ways, the reason I want to put this in, even though I messed up, usually if I mess something up, I don't put it on the test. But two reasons I want to is one, you can see it really is kind of a straightforward one. It's just you have the formula, plug it in. And the other is this is kind of the end of what we were doing with the stock stuff, which is we were working to get this solution. So it then is kind of silly not to have it, since that's the whole idea. This is what we were trying to get to. And it's in the packet, so use it in either of those places. So on the recorded session from Monday, it's hard for me to redo it, so it will have the A squared. If you look in the written notes, I did correct it to have just the A. So the numbers were corrected. So any questions on how you do the 11B? So specifically, kind of, do you remember what? Actually, let me write it down. And just to be difference, let me put a different letter there. So as the reminder, what is this function p of z? I forget where if I got this from either economics or finance. So one of the two was using this phi instead of the usual z. So it is one of these three ways of writing it. So this. So it is the CDF at that point, and depending on which calculator version you have, either it can be the normal CDF of negative infinity, so just something big, negative, and then the value you want to plug in, or if you have the version like I do where it's asking for also the mean and standard deviation, you'd put in the comma 0, comma 1 afterwards. So any questions on this? Okay. So the other one that I was going to do is the last thing we did, because I forget how many, we haven't done too many. So this is similar to 12. And again, let me just change it so it's different. So let's x of t be equal to, let's say, just to be different, at squared. And the density function for a is just 2a, it's like 2, from 0 to 1. And that's going to not be quite what I want, so let me do plus t here. Actually, it would have worked. That's okay. So the two questions I will ask tomorrow is I'll ask you to give me the CDF. And so that, is equal to the probability that the x is less than or equal to the x. You don't have to write this middle one, which is the probability that at squared plus t is less than or equal to x. And let's assume that t is more than 0, so this works. So I get that. Oops. And then since we now have it in terms of a, we integrate over that region with respect to the density function. There's the CDF. And what is the new sample space? Actually, I kind of like this one. The new sample space is, you can see again, this is a fairly simple function on the range. It's just an increasing function. So we just have to put in the numbers. So if I put in a equals 0, I get t. And if I put in a equals 1, I get t squared plus t. And again, you can check to see if this makes sense, because if you put in the left endpoint, the t here, I get the CDF is 0, which it should be. And if I put in the right endpoint, I get t squared over t squared, which is 1, again, what it should be. So at the left endpoint in your new sample space, you should get 0, and in the right, you should get 1. And then in theory, I could ask for the mean and the autocorrelation, but I'll just ask for the mean, because again, there's more stuff than usual. And this one I'd probably just ask you to set up. And you can use what we just got. You would take the derivative of this to make it a PDF and then multiply by x over the range. But since if you mess up, that will mess up your part B, it's easier to just do it in terms of the A, because then you just use the sample space from the original one. And multiply that by the density function. T squared plus t. So just plug in, so to get the new endpoints, plug in the old endpoints. So if I put in a equals 0 into x, I get 0 plus t, so t. So this is a t squared plus t first, not z. And if I put in 1, I get 1 times t squared plus t, so t squared plus t. So just put in a equals 0 and a equals 1. Yes, so t squared plus t. That's not z. So as I said, in theory, I could then do autocorrelation where you have to do the multiplication, but it's already a lot of material, so I wouldn't put that on the test. So in some ways, you can see what's going to be on the test. There will definitely be a Poisson process of some sort, probably a basic one and one of the two follow-ups. There will be a MM1. There will be an MMC of some sort, so 2, 3. That's about as big as it would go. There would be a one where it's changing and finite, so similar to the, which one? a second. To problem 4, the one where we're talking about the number line. So MM1, MMC, with both of them having possible follow-up questions involving the time, and then a finite one. There will be a fixed vector, but as I said, it very well might be one where you can just read off, and then the follow-up question. There will be a stock question where you're asked to find how much you should charge for an option in the basic sense, where it's just stock price now is $50, and then it either goes up to $100 or goes down to $20, and then the Black-Scholes, and then this problem. And as I'm saying it, that's already a decent amount, so there probably wouldn't be anything besides this. So any questions on this? So pretty much those are the ones I want to talk about. So any ones that you have questions on? Three C. Okay, sure. So just so we have different numbers, let's suppose we have MM3. All right, I can't really do it. I was going to make up numbers, but I don't think I'm going to be able to do it without getting. So for this one, we had going in, numbers we need were and this was 3. And we had gotten lambda was 3, mu was 2, and since it's MM3, C is 3. So this one asks, what is the probability that W more than 0.2? All right, so I'll come to the other ones. So this one, you remember that in some ways there are two cases. There is the case I get there and I don't have to wait in line at all. And then there's the case I get there and I have to wait in line. So there are just two cases. So the first question is, in this setup, is we have to get what is the probability that W is equal to 0. And for this one, remember, this is I'm going into the store. I want to know if I have to wait in line. And MM3, remember, means that there are 3 servers, which means if there are 3 people, then there isn't a line. But that means, oops, that's a 2, that the probability that W is equal to 0 is P0 plus P1 plus P2 only, because if there are 3 people when I get there, I'm going to have to wait in line. And then we also have the other thing we need. is this is the CDF for the time we have to wait in line, if we have to wait in line. That's a C times mu, 1 minus rho divided by C, and then that's a W. And I can make obviously a W. So here C is 3, mu is 2, rho is over 2. The rho over C is the 3 over 4. So this is so 3 over 6, sorry. Rho over, so just the 3 over 6. So C times mu is 6. So this is equal to 1 minus e to the minus 3w. So the probability that w is more than 2 is equal to the probability that w is more than 0 times the probability w is less than 0.2, given it's more than 0. And that's equal to 1 minus the probability that w is equal to 0 times this, which is just putting in 0.2 here. And the probability that w is equal to 0 is, so the probability that w is equal to 0 is 4/19 plus 6/19 plus 9 over 38. Subtract that from 1, and I get 9 over 38 for that. Oh, more than 0, so 1 minus. So we want the probability. Oh, anyway, so this is where I messed it up. That's more than. Yes. So P0 is the probability no one's in the store, P1 is 1, and so on. And so probability that I don't have to wait in line. So if I get there, there's no one in the store. Obviously, I'm not waiting. I just go straight to one of the servers. If there's one person there when I get there, I can go to one of the 2 open servers. If there are 2 people, there's still 1 open server, so I can go straight to a server. Whereas P3, all the servers are busy when I get there, so I'm going to have to wait. I'm not sure if that's your question. Okay, so any other questions on this? Okay, so for A, let me look at. And this time, it's only change. Suppose there are 2 servers. Each of them can serve 1 person per minute. And let's let the arrival rate be 3 if there is no one in line, and 4 if there are 1 or 2 people in line. And let's look at the setup. So the first thing we have to do is, and this one, unlike specific ones like MM1 or MM25, as I'm going in, I don't necessarily know how there are, although I sort of do. You can figure it out. So I will go through here, and then we'll fill in. So in some ways, the bottom is the quicker one to do because it is, there's 1, it is the 1. If it's the 2, it is the 2, and then 2, and 2, and then we'll see how far we have to go. So pretty obviously this one is 3, because if there's no one in the store, there's no one in line. What is this second number? So this number is 3. What is this one? Also 3, because if there are 2 people in the store, they are both being served, which means there's no line. Whereas 3 means there is 1 person in line, because 2 people are being served, 1 person's waiting. So therefore that is 4, which means I need another one. And then from 4 to 5 would be also 4. And then 5, now there are 3 people in line, and therefore that would be 0, which means, oops, doesn't really matter. Doesn't really matter because that's where we're stopping. So is that what you're looking for, just this, or did you want to go further than that, Samantha? And the related question, you're okay with getting this set up? And of course, I can change it. So what I'm trying to just make you do is make sure you read it. So if I instead said the arrival rate is 3 if the number in the store is 0, and 4 if the number in the store is 1 or 2, then of course it's different. Because then this first number would be 3, but then the next 2 numbers would be 4. So I can either make this the number in line or the number in the store. No, so again, remember, for this type of thing, we always assume that all that can happen is either 1 person leaves or 1 person enters. So we can only change by 1 at a time. What's missing is time, which is the bigger these numbers are, the quicker things happen. So if instead of 3 that was 30, you still just go from 0 to 1. There's still 1 person entering the store at a time, but it would happen 10 times faster. So if on average now we're getting 3 people per minute, and if it was 30, so 3 people per minute means people come about every 20 seconds. 30 means they come about every 2 seconds, which means we change every 2 seconds or so instead of every 10 seconds. So let me backtrack. There's one other before I go on. Oh yeah, I missed the 9b, so I'll come 9b. So the E of NQ, you can use whenever it's MMC, which means if it's MM2, MM3, you're going to use that to get E of NQ. You can use it to get MM1, but it's silly because you have easier formulas for MM1, which is MM1. We know that E of N is equal to lambda over mu minus lambda. So you can use the formula to get E of NQ first and work your way to E of T, but it's silly because it's just the harder one. So transition matrix, that was on test 1, where we set up a Markov chain. So no. So let me find what 9b is. Start that. Oh, so 9b, again, this is one of these things where in general I could ask you it. forget who asked me. Someone asked me about 9b. Where is it? Oh, there we go. So in some sense, in theory, you should be able to do something like 9b, which is saying, suppose the option price is something other than the price that means that there's an arbitrage, then bind whether there is arbitrage. I forget which way I worded this one. But in practice for tomorrow, I will just have you do something like 9a because you can see there's a lot of material. So let me just say 9b is not on the, will not be on the test. So 9a, yes, 9b, no. Right, other questions? So I should say, as I started this, for the Qs, we in some ways have three things that you should be thinking of as separate. We have MM1, which has its formulas. We have MMC, which has its formulas. And we have finite like this one, where I didn't bother setting up formulas because we can do it kind of directly. So if I want to get E of n, it's 0 times P0 plus 1 times P1 plus dot, dot, dot. And since that's finite, I don't really need a formula to do it. So for me, these are the three types. And for tomorrow, there'll be one of each type. An MM1, which has nice, easy formulas. MMC, which has this slightly more complicated formulas, and then finite. And MM1 has I only gave you the two formulas for the E of n and E of t, but then you can easily get E of w and E of nq. And there's a formula for f of t. For MMC, we have the formula for E of nq, and you can go from that to every other one. And we have the formula for the CDF of w, if w is more than 0. Right, so if you look in the handout at the end of the Qs, there's actually just a page with all the formulas. So instead of me writing a specific one and maybe messing it up again, sorry. Yeah, there's just a page on the handout with all the Q stuff where there's at the end of the Qs sections, there is a page that just here are all the formulas that we have. That's probably better. Any other questions? So as you're thinking, so if you do have other questions, let me remind you, what I'm going to do for tomorrow and Friday is I'm going to break people up according to time. If you don't say anything either on the discussion thread or if you have a separate type of issue through an email, I will assume you're taking it at about the regular class time. I will make the test for that group available starting around 4:25, and you'll have about an hour and a half. If you're taking it Friday, it looks like starting at 3:30 works for everyone, but I'm going to wait to make sure there isn't anyone else. And then I'll send an email telling each of them, and they'll be in a second group. And then I think there's at least one more person who wants to take it earlier Thursday. They would be in their own separate group. So as I'm setting up the different groups, I will put you in the one that starts tomorrow at 4:25 unless I hear from you in some form. And again, for tomorrow, at least during the class time, I will be available for questions on both the Blackboard Ultra, this thing, and I'll also have Zoom open. So you should at least, and when I send out the announcement, I'll put what the link is for the Zoom. So you should at least have those sort of available so if a question does come up. And again, If you have a problem submitting through Blackboard, which seems to happen to about 1 in 5 people, then just send me it as an attachment with an email. So any questions? Okay, so I'll do the usual thing. I'll stop recording in a second. I'll stick around because we still have class time. So if you have a more specific question, stick around. Remember, so either is okay. I think fall, we didn't get as far for test 2. So I think this spring 2019 is probably better of those 2. But if you look at that and then 1 or 2 of the previous ones, you can see how that some of it is similar. So remember, this is the last thing. So we have a test tomorrow, Friday, and then we are done. So I will be here during class time on Monday, but you do not have to be. The only reason you would come in is if you have quick questions about general stuff, or if you want to just talk about the class. Hopefully I'll have test and take home done by then, but also have another test that I'm also grading right now that I also want to try to get by Monday. So I wouldn't be surprised if it ends up being Tuesday. But certainly by Tuesday or when pushing it back a bit, but certainly by the middle of the week, I have to have it done because then I get into the next stuff. So since the last one, since obviously we're not going to talk tomorrow, as I said on Monday, thank you for being in the class and good luck with your finals and stay safe. Don't go outside too much. And so I'll stop recording and I'll stick around so if you have more specific questions.